Hello, my name is Miranda Bean, and I will be doing exam question number 40, which talks about the good old-fashioned artificial intelligence approach to robotics. So one of the famous historic achievements of early robotics, which is also an excellent illustration of the physical symbol system hypothesis in action, is Shaky. So Shaky, named for its jerky-like movements, is a pioneering robot developed in the late 1960s and to early 1970s in the Artificial Intelligence Center at what was then called the Stanford Research Institute. This robot was the first of its kind that could move around, perceive, follow instructions, and implement complex instructions in a realistic environment. The programs built into Shaky permitted it to plan ahead and learn how to perform tasks better. So in this picture over here, you can see Shaky at the bottom left-hand corner. And then you can see a map of Shaky's physical environment where each room has a name and the total environment measures around 60 feet by 40 feet. In the room labeled right above Shaky is a mystery room where Shaky has no information about its contents. Doorways are labeled with a D, and the environment is pretty much empty other than the room RCLK, which has 3 boxes in it. The software that allows Shaky to run is not actually in the robot itself. Rather, it's in a completely separate computer system that communicates with Shaky by radio. So what are the strengths of the good old-fashioned AI approach to robotics? So the robot Shaky is an example of how a physical symbol system can interact with a real physical environment and reason about how to solve problems. So this is a really good example of this hypothesis. And also, Shaky clearly illustrates the heuristic search hypothesis. And this hypothesis basically states that an intelligent program solving tasks by transforming and manipulating symbol structures until a solution structure is reached. And the world of the good old-fashioned AI robot is already defined for it in terms of a small number of basic concepts. And this essentially avoids the real-world problem of decoding the environment and reacting to the challenges that it proposes. So the weaknesses of the good old-fashioned AI approach to robotics is that in programs such as Shaky and Shirley, they can interact virtually with their environments, but situated cognition theorists argue that they are not properly situated in their environments. The real work of putting intelligence into these agents is not done by the systems themselves, but by the programmers. And these theorists also think that instead of focusing on simplified and scaled down versions of high-level tasks, cognitive scientists should look at how simple organisms, such as insects, solve complex but ecologically valid problems. And the last thing I want to talk about is behavior-based robotics. So behavior-based robotics takes another approach differently than that of the good old-fashioned AI approach. And this approach is more in the spirit of the situated cognition. Behavior-based architectures, like that of Toto, represent their environments and use those representations to plan actions. But these representations are not centralized or centrally manipulated. Behavior-based robotics have a basis behavior programmed into them. And these basic behaviors are more complex and temporally extended than reactive rules, and they can also be combined. Behavior-based robots can exhibit emergent behaviors that have not been programmed into them. Behavior-based robots have also been shown to be capable of learning these emergent behaviors through reinforcement learning. That concludes the end of my presentation. Thank you.